3 points NP and V are shown on the following diagram. NP is 20 meters, PV is 25 meters, and the angle VPN is 55.5 degrees. Question A, find NV. You can see that three sides and an angle are involved, so a cosine rule can be applied. The formula is given in a data booklet. It says that side squared is equal to the sum of squares of two other sides minus 2 times these sides times cosine of the angle between them. Notice that this side and this angle are opposite. So NV squared is equal to 20 squared plus 25 squared minus 2 times 20 times 25 times cosine of 55.5 degrees. Using a calculator, first of all, let's check. We need degrees, not radians. Square root of 20 squared is 400 plus 25 squared minus 2 times 20 is 40 times 25 times cosine of 55.5 degrees, and it becomes 21.43 significant figures, meters. Question B, find the angle PNV. This is required. Since NV is found, you can see that 1, 2, 3 sides and an angle are involved, and we can use a cosine rule again for the angle. Just solve for this. It is given in a data booklet that cosine of C is equal to A squared plus B squared minus C squared over 2 times AB, and notice that this angle and this side are opposite. And if you use cosine rule, you get the answer directly. But if you use also, you can use a sine rule. We need pairs, side and opposite angle, so NV over this 55.5 is equal to 25 over sine of this angle N. But if you get that, and if you solve for sine E, and if you get, for example, sine is sine of some angle is equal to, for example, 0.5, you use a calculator, and calculator says that it's 30 degrees. But for triangles, there is another possible solution, which is 180 minus 30 is 150. It's because for triangles, possible angles are from 0 to 180, and the sine of theta and the sine of 180 minus theta sine is the same. So there may be two possible solutions, and then how to choose correct solution. You can use the next. If there is an obtuse, it's an angle greater than 90 degrees, it's impossible that another be also obtuse greater than 90. So you choose that it's 30, not 150. Or you can use that the greater side is, the greater opposite angle is. But if you use cosine rule, you get the correct answer directly. So let's use cosine rule. So cosine of PNV is is 20 squared plus this, but you should take the exact 21.4 squared minus its opposite, it's 25 squared over 2 times 20 times 21.4 and so on. So it's 400 plus 400 plus just the answer squared minus 25 squared and divided by and divided by the answer. And then just the inverse cosine of the answer. To get 74.2. to 3 significant degrees to 3 significant figures. The next question, see hence or otherwise, find the shortest distance between P and the side NV. The shortest distance is a perpendicular distance. Let this point be H, and PHN is a right angle triangle, and angle N is found, so we need PN, and we can use calculator. So with respect to the angle N, PH is what? Opposite, and PN is hypotenuse, opposite hypotenuse, so we need sine. So sine of PNV, it's opposite PH over PN, it's 20, hence PH is just multiply both sides by 20, so it becomes 20 times sine. So it's just 20 times sine, and again you should take the exact sine of the answer. And it's 19.2 to 3 significant figures, meters. Another method, it's not useful here, but in general we know that area of a triangle is a half times 2 sides times sine of the angle between them, so it's half times 20 times 25 times sine of the angle between them. And also we know that the area of a triangle is equal to half times base times height. It's also equal to half times NV times PH, and V is found, and you can solve for PH. In general, this method also can be applied. So hence the shortest distance between P and NV is 19.2 meters. And that's all for this question.